Welcome to the Andreas Orthey podcast series on robotics. My guest in this episode is Majid Khadiv. Majid is a professor for AI planning in dynamic environments at TU Munich and one of the experts on locomotion for humanoid robots. We will talk in this episode about his unique path from being born in Iran to become a professor at the TU Munich, how he has the ability to visualize dynamical equations in his mind, and of course about the future of humanoid robotics. I'm happy that he was able to join me. Please welcome Majid Khadiv.
Hi, Majid. Thanks for coming onto the podcast.
Hi, my pleasure.
So what I really want to talk to you about today is humanoids and how to control them. And I think you are definitely the perfect person to talk about this. Because you have actually a research lab at the TU Munich where you research humanoid robots and how to control them. But before we go there, maybe we can talk a little bit about your background.
Yes.
You're originally from Iran, right?
Yeah.
So how was actually your childhood in Iran, and how did you actually get to the point where you wanted to study mechanical engineering?
Yeah.
So how did this? How was your path towards that?
Yeah, I'm sorry I don't have any, interesting story.
Yeah.
So we have an entrance exam in Iran before the university,
Mm-hmm.
and it's a very heavy exam. So you study for it for 1 year, and
Okay.
it's 4-hour exam. It's very stressful and everything. And then when you have a very good rank in the exam,
Mhm.
then normally, and I did in the math and physics, my major in the high school.
Mm.
You go, at the time, you would go either to mechanical engineering and electrical engineering, right? That was the path. And
Okay.
since I didn't like so much electrical engineering at the moment, I went for mechanical engineering.
Okay. But was there like a point in your life where you realized you wanted to actually do mechanical engineering and not, for example, something like physics,
Yeah.
computer science?
hmm To be honest, I always was fascinated by physics,
Mhm.
right? I still love physics. I read a lot about physics.
Mhm.
And the main reason that I went to mechanical engineering because I liked so much the physics of mechanics,
Mhm.
That was the main reason. Because I was already in the, mathematics and physics.
Mhm.
I think the closest thing that matched my interest was mechanical engineering.
Mhm.
Then I started in the bachelor. I didn't like all the courses, but again, the course that really attracted me was dynamics,
Mhm.
which is about dynamics of motions, right?
Mhm.
And there I figured out, okay, this is exactly what I want. Then I did a bit of control. It was very complicated, but still I said, oh, that's cool because now I can control my dynamics,
Mhm.
right? I can steer the behavior of the whatever object it is.
Mhm.
And that's why, that was the point that I said, okay, I want to do something like this.
How did you become interested in physics in the first place? So was it like a teacher who was really inspiring, or like you read some more sources, or how does this?
To be honest, I don't know, but I think in the high school, this was the thing that I felt I know internally,
Already.
It's just, it's like my intuition. Okay, I talk to many people in my field.
Mhm.
There are some people who their intuition comes from math.
Mhm.
My intuition comes fully from physics, nothing from math. If I look at the equation, I don't understand anything
Okay.
until I can feel them physically, then I understand that.
So what does it actually entail to feel something physically? So would you say that it's basically in your genes of how you think, or?
I think so. I think it's exactly the way I think is about physics. It's about, the prediction, how the motion of something will evolve into the future.
Mhm.
And yeah, this is the thing that, okay, math, it's okay. Not that I hate it, I like it,
Yeah.
but it's not my thing because, again, it's not the thing that I feel like. So whenever I look at that equation, I try to imagine what it means in the physical world.
Mhm.
If I don't understand it, I never can,
And when you say you try to imagine it, is it like that you try to visualize the problem somehow?
Yeah.
Or how does it work
Yeah.
for you?
It's all about it's not visualization in terms of geometry.
Mm-hmm.
It's visualization about how things move over time.
Mm-hmm.
So I always think about it like this, if what happens if I, for instance, do this action to this equation,
Mm-hmm.
how it will evolve over time,
Okay. So basically in your head, things are starting to move and you're trying to imagine how the path of all the objects
Yeah.
involved is looking like. That's interesting. So I think a lot of mathematicians, they actually say that they're also trying to visualize things, but I think mostly what I hear is it's always about like trying to imagine something or visualize something which is static. And you would actually say that you try to do the same, but like for more like a motion type of thing.
Yeah.
And
Actually, we had a class or course in my bachelor that called static.
Mhm.
I didn't like it. It was about when the system is statically stable or balanced, let's say.
So you're more the dynamics.
Dynamics, how systems move,
Yeah.
It's all about movement for me.
And then, of course, it made sense for you to go into mechanical engineering, right? So you already said that you have like this entrance exam,
Yeah.
and it's super difficult. So how does it actually work in Iran?
I mean, again, so at the moment, I was in the field of field of mathematics and physics. At that time, that was the hot topic. Now it's not anymore. Now experimental sciences are the hot topic.
Mm-hmm.
But at the moment, it was really the mathematics and physics. And then it was a very intense competition. Let's say there are 350,000 students that attend countrywide. They
And that
attend
is-
this exam.
That is all for mechanical engineering? Or
No,
is
this
that
is for engineering, all the
entrance?
engineering.
Okay. Yeah.
And then, for instance, when you get something that is below 1,000, this is good enough. You can go to the good universities. If you go below 100, then you can go, for instance, to the best university.
And is there a really big difference between the universities in Iran?
Um,
So is it more like, is it similar to like Ivy Leagues in the US versus like maybe like some community college in the US where there's a stark difference between
Yeah. I think I would say the universities of Germany are much more unified,
yeah.
right? They are somehow similar quality. But there, no. I think so. The universities in Tehran normally are much better,
Mhm.
and everybody wants to go there.
Mhm.
And also in some of the cities. So my bachelor, actually, I didn't do in Tehran, but there was another good university
Mhm.
in Isfahan, which is a city close to my hometown. I went there for my bachelor. But for my master and PhD, I went to Tehran, basically.
Mhm. So you changed universities in
Yeah.
between.
So it's normally, again, the people who get the best rank goes to the best university, right? There is a clear or very standard kind of ranking of the universities.
And did you actually have to like prepare a lot of time in advance for this exam?
Yeah, I did 1 year of
What?
full day, right? Every day, maybe, I don't know, 8 hours, 10 hours of studying for this exam.
And you have like special classes for that? Or how does it work? Is it you study on your own?
So basically, yeah, you study on your own. Basically, in the year of so we have after high school, we have 1 year called pre-university.
Mhm.
And that time, you don't have a full year of classes. It's a bit shortened, right? And then it's a bit more relaxed, let's say, the courses.
Okay.
You have enough time to basically spend for the basically entrance exam.
Mhm.
And actually, it's called concours, which comes from French language,
Ah,
right?
okay.
So
Yeah, I heard that they have something similar there.
yeah.
Okay, and so what kind of things do they ask in those kinds of exams?
It's crazy because it's very wide. So basically, you have literature, you have English or any other foreign, not any other, some other foreign languages.
Mhm.
I think you could choose German if you wanted.
Okay. Also, so you have a little bit of choice in what kind of topics you want.
Only for the foreign language.
Oh, okay.
Only for the foreign language.
Not for everything.
No, literature is fixed, and then you have mathematics, physics, chemistry, and something. I don't remember everything. Yeah, I think that was it.
Mhm.
and you have few questions for each topic. And this is the whole, the questions can be from the first grade of high school, second grade or third grade, or pre-university.
Really?
It says, it's a very dense exam.
Wow. And so what was your best and your worst topics?
My best topic was physics.
Wow. Of
My
course.
worst topic, I mean, it also depends, right? Because that year mathematics was super difficult.
Mm.
My worst percentage was mathematics, but it didn't mean that, but yeah, but in physics, I did very well, basically. But in mathematics, it was okay. But also, it was a bit low, but all people were low, because it was difficult that year, the mathematics.
And then you got like a very good rank, I guess. Right?
Not super, super good, but good.
And then you could like choose what you wanted to do.
Yeah.
Okay. And then at some point you decided to do mechanical engineering,
Exactly.
right?
Yeah.
And so how was studies like? And was there maybe a specific point where you already like felt this, I don't know, attraction of robotics?
So in bachelor, no. So in bachelor, I got interested in dynamics and control. And to me, robotics is a combination of these two, dynamics and control. So I didn't know. I said, oh, I like this, but I don't know I still didn't know that robotics would be the best thing that can really bring these two together. I started my master, and then first semester I had the robotics course, and I said, oh, okay, that's exactly what I want to do.
So how is actually the structure of bachelor, master, and PhD in Iran? Is it basically that you have like 3 years of bachelor, 2 years of master, and then you start a PhD, or is master and PhD somehow like interrelated a bit?
No, basically you do 4 years of bachelor. Then again, there is another entrance exam. And then again, if you get a very good grade, you go to better, university or so on. And then you have 2 years of master. There is another entrance exam, and then you go to PhD.
Okay.
Because since this is the national universities, basically, you don't need to pay any tuition fee, right? So they select based on this entrance exam.
Makes sense. And so you basically changed university after 4 years of bachelor, and then you did 2 years of master in Tehran, right? Yeah. And so how was that change? So this transition from your university. So which university was?
Isfahan. So it's a beautiful city in the center of Iran, actually. Yeah.
Okay.
Yeah.
And so was it actually a big change from this university to Tehran?
It's not like immigrating from Iran to Germany, right?
I don't know.
No, that was just huge change for me. That was so big of a change. But no, going from Isfahan to Tehran, it was okay. I wouldn't say it was a big change.
And in terms of like difficulty of the courses, was there like a difference, or was it roughly equivalent?
To Germany?
No, between bachelor.
No, they are similar.
Similar. Okay. Yeah. And then how does it actually work for a PhD in Iran? So, I mean, you said that there is an entrance exam, and if you admitted, then you can basically choose the supervisor.
So PhD is a bit different. So the bachelor and master are the same. So based on the rank, you go to university. For PhD, there is this written kind of exam. And once you pass that, you can choose some, different university and some different supervisor. And then you are invited for interview. And based on the interview, if the professor wants you, then you can,
And so the entrance exam, is it markedly different from the one which you had for bachelor and master, or is it roughly equivalent?
No, the one to go to bachelor is the most competitive one.
Okay.
It's very difficult. But then for the master, it's okay. For PhD, it's very cheap.
But is it different in terms of like questions?
Yeah. Because for the master, basically, when you go for the entrance exam of master, it's much more focused, right? Now you do it in mechanical engineering or in, and then for PhD, it's even more focused.
Okay.
But for in terms of bachelor, it's very general. You do physics, chemistry, mathematics, literature, everything.
And so for the PhD entrance exam, what kind of do you already choose the topic of robotics, for example, or of control, or?
No, actually, the professor, and then basically you go directly to a topic, I said I want to do, so my supervisor of the master thesis and PhD were the same.
Ah.
And then so in my master's, I started working on humanoid in my thesis, and in PhD, I knew that I wanted to do the same thing. So.
Nice. And can you still remember maybe your first paper which you wrote?
Yeah, I mean, I did it from my master thesis. I'm very embarrassed. I don't want to look at it again.
Well,
but yeah, I remember very well. It was a conference paper I wrote. Yeah.
And you roughly remember the topic?
Yeah, I remember it very well. I don't know too much.
Okay. And then at some point you had to choose a very concrete topic for your PhD thesis, right? So how did you actually get to this topic?
So it started from my master thesis. So I worked on the motion planning of humanoid robots. And then I saw that, it's a very big topic and there are a lot of problems that are unsolved. I said, okay, this is enough for me to do the whole career around until the end of the professorship. And it's true, actually.
And so what did you actually find out during your PhD, or what kind of problem I mean, you didn't take everything in motion planning, right? But what kind of subtopic did you take on?
So I was working, I worked a bit on the evolutionary methods for motion planning at the moment. And at the same time, I was focusing on friction. So contact and friction. So I wanted to find an adaptive controller that can change the behavior of a robot based on the change in the environment in terms of friction. So it was a kind of adaptive control. And also a bit on the planning side, I was mostly thinking about, again, evolutionary algorithm to generate stable motions, let's say. At the moment, actually, I was not so much, I didn't think about it so much through gradient-based optimization and more, optimal control way. So this is the thing I knew, and this is the thing I did,
And was it maybe a kind of demo or something which you demonstrated at the end of your PhD?
Yeah, because so I was very lucky because at the start of my PhD, there was a project started called National Humanoid Robotics Project. And randomly, somebody in that team knew me, and they asked me if I can join the team. And I said, yeah, I mean, that's exactly what I want to do, right? And that was crazy because it was a big team from electrical engineer people, I don't know, mechanical design and so on. And we started building a human-sized humanoid robot. And that was the start of my, doing experimental thing. And 3 years of my PhD, I did that, basically. I worked on that project, basically. And then I joined Max Planck for an internship during my PhD for 1 year.
But yeah, what kind of scenario did you show at the end of the PhD with your humanoid robot?
So actually it was crazy because at the end of that project, we had to do a live demo of a humanoid robot in a scene in the university. And there were really authorities there. So from the Ministry of Science and so on, right? It was a crazy, and to be honest, we had a lot of technical problems before the demo. And we had something like 50% it would work. So we had a 1 to 2 chance of not working. And it would be embarrassing, right? The robot would fall down in a live demo. So luckily it didn't happen.
And so what did you want to show in this live demo?
So the robot would start from one point, walk a bit, then move on a curve. It started in the front of the audience. It started, talking to people, introducing itself. Then it would do some I don't know, weird balancing behavior. Then it would do a bit of imitation learning. So human would just raise the hand, and the robot will do the same, and so on. Then it would walk to the end corner of the scene, and then say goodbye, and that's it. It was like 10 minutes.
Wow. Okay, that sounds intense. So did everything actually work?
Everything worked.
Everything worked.
I mean, again, if you you would do it before the demo, 50% it would fail.
Chances are not too bad.
Yeah.
So you already said that the change from Iran to Germany was really huge. So how did you actually get the position in Germany, and how did you experience this change?
Yeah, so basically I was at the moment I didn't know at all about the Max Planck Institute because there were the department that Stefan Schall was there, and then Ludovic Righetti was the person who I went to work with, and I didn't know about them. I just was reading papers from different people, and Ludovic had a paper in the IGRR, which is the best journal was the best journal at least in robotics, on the exactly the same topic I was doing, but in more advanced optimization based way of doing this. And I found it very interesting. I contacted Ludovic. I said, yeah, I want to do an internship with you. So first time he didn't reply. After 1 week, I wrote a follow-up, and then he immediately replied.
Nice.
He said, explain more. Do you want to talk? And then, in the second time, so the first time I just sent my CV. The second time I sent some videos of my robot. And then I think that was the point that
So that is how you actually get positions by just sending cool videos of robots, and then people are hooked.
Exactly, I think. At the moment, I didn't know that the thing I did was super good. I was saying, oh, it was, just some random thing I did. But now that I look back, actually, it was quite impressive, We didn't know anything, right? We were just few PhD students that we worked together, built the full robot. And I mean, there were also few engineers.
And then you started basically an internship at Max Planck in Stuttgart, in Germany.
In Tübingen.
In Tübingen.
Yeah.
So for how long was this internship?
1 year.
1 year?
Yeah.
Okay.
Yeah.
And so what was your position there?
It was internship, basically. It was...
Okay, so it was not a postdoc?
No, still I didn't have my PhD.
Oh, okay.
I didn't defend yet.
It was basically during your PhD.
Exactly. Yeah.
Okay. Nice. And so how was the change from Iran to Germany?
It was very different. I mean, I didn't expect at all like that. Everything was, in the opposite of my expectations somehow.
So what was the biggest difference between Iran and Germany? Maybe first culturally, but then also like from a research perspective. So I guess there's also a big difference between how people approach research and research questions. Right?
Yeah. So I think I was very naive, very, very naive actually, before coming.
Okay.
And because, the way I imagine Germany, I was like Hollywood movies,
So how is Germany actually portrayed in Hollywood movies?
I mean, not Hollywood. I thought, the West is the same. It doesn't matter if you go to Germany or
the US.
United States or to the UK, it's just there, or France. It doesn't matter. Really, I was just saying, oh, this is the abroad, and that's the best for me, And there's the East also.
Of course.
And then when I came here, I didn't expect that. Everything is the buildings are so old. It's raining all the time. I don't know. Things are not modern, actually, I would say. I thought, that, it's like, I would think always about, it's a super modern type of country. Like, I don't know, whatever, right? It was not like that. And I thought, it would be easy. I go talk to people, be friend with them. And in the lab, people were super nice, to be honest. But I didn't have anything in common to talk to them because it was an absolute, it was weird to me, the things they would talk about. Because in Iran, we would say, we would talk about our common memories, about the politics and so on. And I didn't have anything common to talk to people. And I became a bit, isolated. And it was because of me. Not people were super nice. The lab.
So was it actually an international lab?
It was an absolutely international lab. I still love that lab. People from there, and but I became super isolated. I lost a lot of my confidence. Right? I really started to feel, I shouldn't say this, I shouldn't talk, and it was difficult. And at the same time, in terms of research, I think things were super different to me. Because the way I saw the problem was through the lens of mechanical engineering mostly. And in Max Planck, everybody was a computer scientist. Everybody was talking about learning, machine learning.
Mm-hmm.
And I didn't know at the moment if it was a thing. So I said, okay, I don't know why people are talking about these things. These are not the problems.
Mm-hmm.
I think there are, balance of the robot is the problem. Why nobody talks about that?
Mm-hmm.
People show, I don't know, pole balancing or I don't know, bringing an inverted pendulum to up. I said, okay, fine. But, and then, and I was not really doing the type of optimal control things. And I had a lot of discussions with Ludovic. We still, whenever we talk, we remember that time. And he always tells me, remember, you didn't want to do optimization. And now all my research is based on optimization.
Mm-hmm.
And I said, yeah. And we had really heated discussion on this. I said, no, why does it matter how you generate the motion? It doesn't matter to me. And he was saying, no, we need to make it more systematic, to study through the systematic framework and so on. I said, okay, I'm doing control and I'm fine with that. We don't need any optimal control. And now I'm exactly doing that.
Nice. And so what kind of questions did you actually work on in Germany? Were they kind of like related to your PhD or a bit different?
No, it was related. So I was working on still humanoid locomotion.
Mm-hmm.
But there was a robot in Max Planck that was much more complicated. And the robot didn't have ankle joints. And from knee below was the prosthetic fit,
Mm-hmm.
right? So it was just, let's say, a rod attached to a prosthetic foot. No actuation.
Mm-hmm.
And this makes it like a human walking on a stick, right? It makes the balance problem much more complex. And so first I argued a lot with them, why are you doing this? Still, we don't know with a normal robot how to walk, but this is really much more complicated.
So how was actually the robot called, the one which you just described?
It was Athena. It was the name of the robot was Athena. And yeah, then I started working on that. First off, I didn't believe in it. I thought it's such a difficult problem. We are not at all there to solve this problem. But at some point, it changed my way of thinking so much that I came up with an algorithm that still I love it. And that was all because changing of my mind, the way I look at the problem. Now I said, oh, you cannot be any more, statically stable and, cannot be very conservative. You should be very fast stepping. And if you look at the robots nowadays, all of them are like that. They are stepping fast to balance. They are not relying on the just a static balance or something like this.
So basically the problem you tackled was stability and balance for the Athena.
Exactly. So it's still for this robot, walking was still very difficult because again, it's like a human walking on a stick, and it's very difficult to do that. And I worked on some, something. I mean, it's more technical, but timing optimization for generating motions for robot, and in a very loose terms, it means that you are walking. If somebody pushes you, you step quite fast to recover. And I could basically devise an algorithm that can do that. And it was a very simple algorithm that, it never happened before. People could not formulate it like this, And again, it came from, the way I look at the problem through simple physics, But still, if this robot was not there, without actuation and ankle, I would never think about it like this,
So basically your innovation there was really to not let the robot try to counteract whatever force comes in by just changing its motor angles or something.
Exactly.
But instead you actually make really a complete step with the robot.
Exactly. You adapt the location and timing of the step such that you do not fall down. And you all continuously do it. You don't care about current state. You always look into the future. Next step, where to put, when to put the step. And you all the time did that.
And so the algorithm you developed, how is it called?
It was still through the framework of model predictive control, but the formulation I proposed was the first convex optimization that could do step location and timing adaptation. And this was a big deal because when you do convex optimization, it means that you're always guaranteed to find a solution if there exists a solution. And this was the thing, and it was super fast. So you could, at frequency of 1 millisecond, change the step location timing based on. So if somebody pushed you, you could quickly change the location and timing to recover from that. So it was highly reactive controller.
And what kind of assumptions did you put on the system? Was it like a region where the robot was allowed to step? And also, I guess if you have like if someone really pushes you, sometimes it's not enough to only like do one step, right? So what about your algorithm? Would it also be able to like do two steps?
Exactly. This is the beauty of the algorithm. So I showed with the theoretical guarantee, that in order to recover on a flat trail, you only need to look into one step into the future. There is no need to look into more steps. And I with guarantee. So basically, I showed that with the optimization problem that I wrote, there is a guarantee that if the robot can recover with taking infinite steps, my program will find infinite steps to recover from that. This is called viability. And viability means, does there exist a sequence of actions into the future, right? Such that the robot doesn't fail at infinity, let's say. And I showed that you don't need to look into the future until infinity, which means that you would need to solve a very big optimization. Just looking at the next step is enough. And what you do is that you can put your foot somewhere that you can maximize, the probability that you would recover into the future.
But I guess you need some additional assumptions there, right? So if the force is really big, then you don't have like the ability to actually make it step, right?
In one step, what you would do is that you would do the best thing you could do, which would you take in the minimum time, put your foot in the maximum reachable area, and the algorithm could find that. In one step, you cannot do more, right? In one step, you cannot do multiple steps. And in the next step, it would do exactly the same thing. In the next step, it would do exactly the same thing. And it could go to infinity if it's required.
But what kind of assumptions do you do on like the direction of the force, for example?
Nothing.
So basically, but if I just push the robot,
then because so basically I was using still the model that is called linear inverted pendulum. And linear inverted pendulum means the height of the base is fixed.
Okay, under this
under this assumption, of course, if you want to solve a viability for the whole body system, it's an interactable problem. So you need this assumption. Exactly.
Then you actually finished your PhD and you went back to Iran for that. What did you actually do after your PhD and what kind of like options did you entertain?
So I went back. So I needed to finish my PhD, but still I needed to wait such that the results of my submitted papers, come. So I had to stay there for, I think, 1 year still, until I have all the papers out and I'm, prepare for the defense and do the defense and so on. And then as soon as I finished my PhD, so basically I wrote my thesis, revised my papers and all this kind of thing. So I didn't do any new thing. And I spent time with family and, chilled a bit because it was a really intense 4 years.
I imagine.
But as soon as I defended my thesis, the day after, I contacted Ludovic again. I said, do you want a postdoc? And he said, yes. And then, I started a postdoc after that with him.
Wow. And then everything went quickly. So basically,
I mean, the visa didn't go quickly, so it took them 5 months.
Oh, right.
But after 5 months, I came there. I came to Germany.
Okay. And then how long was your postdoc actually?
Very long. So I started in May 2018. I was somehow something like 4 years with Ludovic. And then 1 year still in the same institute, but in another department with Bernard Scholkoff. I did 1 year and 3 months. And then I started in Munich.
And that was also postdoc?
That was also postdoc,
Okay.
Because I still was applying for a professorship position.
And then how did it actually, so how long did it take to actually get to a professorship position?
Oh, that was the longest story. So I started very early. I was not thinking it still. So after 1 year of my postdoc, there was a position of junior group leader open. And I just said, okay, why not? I mean, I cannot start. I talked to Ludovic. I said, should I apply? And he said, yeah, why not?
Mhm.
I said, I don't think still I'm ready. But he said, no, you are ready. Just apply.
Mhm. So why did you think that you're not ready to apply?
Because I thought still I don't know anything. And I thought there are a lot of things I need to learn. I need to expand my knowledge in different type of areas. And yeah, I thought it's still I'm not ready. But he said, no, you're ready. And then I applied. I got the position and I didn't go.
Really?
Yeah, it was
Why didn't you go?
yeah, it was a crazy story because um, I thought, okay, staying in Tübingen would be much better for me still.
Also, the position was not
It was
in
not-
Tübingen anymore, but
No.
it was in Stuttgart.
Stuttgart, exactly. So it was in the University of Stuttgart, and then they invited me. I went there, talked to people. I think it was very nice position, but at some point, I don't know why, I thought that if I stay in Tübingen, I can still explore a bit more,
Mhm.
expand my knowledge, and still because at the moment also I still was working with co-supervising some PhD students of Ludovic in Max Planck, also master students. And I thought, we already built a couple of robots there. We were about to make them work, and it seemed that if I move, everything would be shut down.
Mhm.
And in Stuttgart, they didn't, I mean, maybe, yeah, but they didn't, they said no. So I was thinking they would say, oh, you can be 2 days in Max Planck, 3 days here, I would be more than happy to join. But they said, no, you should be full-time here.
Mhm.
And then at some point I said, no, I said, I'll just stay here. And it gave me so much confidence. I said, okay, well, I can't get any position, so I can wait a bit. And it was a very bad decision because it didn't happen. And in retrospect, for sure, I would accept the position.
Mhm. And then you basically applied to more positions.
Yeah. At that moment, so I said, oh, it seems that I can get positions. So
Mhm.
I started applying.
Mhm.
So this was 2.5 years after my postdoc.
Mhm.
I started applying to different places all around the world, actually.
Mhm.
At the moment, there were not many positions in Germany. I don't know why.
So I think one important metric there is always the H index
Hmm.
for people who are applying. So what kind of H index did you actually had at that time?
To be honest, I don't know.
So you didn't really care about it.
I don't remember at all. At the moment, also, I don't know what's my H index. No, really. I don't know. I know my papers, right?
Mhm.
And I know which one is which one and how it works and stuff, but I don't know about it. I think it's the order between, I don't know, 20 to 30, something, or I don't know, 20 to 40, I don't know.
Mhm.
At the moment, I really don't know. I didn't have many good papers still. Actually, the time that I didn't go to Stuttgart, the next year, we could do a lot of nice experiments, and actually I could publish a lot.
Mhm.
And that year was really nice. At some point, I had my publication record got much better.
Mhm.
And then I started thinking about going directly for professorship positions, not a group leader position, basically.
And so was professorship in Munich the first one you applied to? Or?
No. Basically, it was one of them. No, applied for many others. So I got 2 or 3. So I got invited to many places for interview, but I got 2 or 3 positions in UK,
Mhm.
one in France, and for Munich it took them 1 year to get back to me. And in the middle, I accepted another position in France. And then when TUM told me that no, you are accepted, then I had to cancel that and go back to TUM. So it was not a very nice time. It was very stressful. And I'm this kind of person that I feel so bad if I commit to say something and then say no.
Mhm.
I had a very stressful and difficult time. Yeah.
And so how was it actually to build up your own lab in Munich?
That was
Changed for you.
That it didn't change much because I already had a lot of experience in Tübingen,
Mhm.
coordinating with the group, co-supervising the students and so on. I knew exactly what robots I want. I knew exactly how many students I want. I knew exactly what kind of funding I should apply for, you know. So everything was for me pretty much clear what I should do because I had a lot of experience, right, during my postdoc.
And so, what about Munich? How easy was it actually to find a location, for example?
I was so lucky. After, yeah, I think after 2 weeks I could find it.
Oh,
But I know that people spend 1 year still searching.
yeah.
I was super lucky, and it's a very good location. I love my flat. It's because I wanted to be in the city center, somewhere really, you know, like city-like style, and it is exactly that. But I was super lucky to find it right away.
Nice. And so in terms of students, you already said you knew what kind of students you wanted. So what would be like an ideal student for your lab? So what kind of background attributes they should have? What kind of studies should they have concluded?
To me, that doesn't matter, the studies they had. It's important that they understand what they did. So in my interviews, this is exactly what I do. So I tell them to present and I ask questions about the work they did. It can be super irrelevant, right? And to me, it's important about that they understand what they are talking about, you know.
Okay. So basically your approach would be to go like really into deep technical problems and trying to find out, do they actually know their stuff? Did they actually do the work?
Yeah.
Okay.
And I tell them when you prepare presentation, go as much as possible to technical stuff. Writing math, I only want to see math. Nothing else. I mean,
I thought you hate math.
No, I didn't hate. I don't hate math. I mean, it's a tool. I don't love it.
Yeah.
But something that it's a necessary tool. So
yeah, for sure.
So I tell them to be as technical as possible. Some don't do it, which means to me it's a red flag. So I ask you to be as technical as possible. So if you don't do it, it means that you didn't do it. So I'm basically disclosing all my tricks. And then when they do go through technical stuff, then I can see, you know, how much they understand what they did. And to me, again, I really want somebody to bring something new to my lab. That's the most important thing. A new mentality. And I really don't want something to ask me all the time what I should do. What's the next thing? I want somebody to fight for their belief. Whatever it is, it might be wrong. We can discuss 100 times. We can, you know, fight. And at the end, you know, we just, you know, find the middle point somewhere.
So you're basically trying to have really also like a diversity of minds there, like different topics, different subjects that they bring to the table. So what kind of students, so what kind of topics do your students actually have graduated in, for example?
So mostly on the optimal control and machine learning for decision making, right? This is the general topic. And now at the moment, I have 5 PhD students who are working on different topics in this area. So it's at the intersection of machine learning and optimal control and optimization for robotics. And the end application is humanoid, which is a combination of a lot of the locomotion, manipulation, perception, everything, right? It has everything.
And do you think that there are still like some topics maybe like underrepresented, where you think, okay, those are really things which students should have, but they don't get it from their studies at the moment?
You mean the courses?
Yeah, maybe something which we could like inject into a curriculum and which would be really helpful for students.
I think so. I think so. I started 2 new courses at TUM actually, and the thing that I see is a bit general lacking, and many colleagues share the same thing with me, is that most of the courses somehow are introductions rather than going very deep to the topic. And my courses, I wanted to go deepest to the topic that I'm teaching.
Okay, and so what kind of courses do you do?
So I have 2 courses. One is called Foundation of Modern Robotics. And there it's very mathematically oriented. So I start from Lie theory and, go very deep into math and so on. So students at some point get really lost and they hate me, but I think they will appreciate that at some point.
Yeah.
And then I have an advanced robotics course. I talk about contact only, contact rich robotics, it's called.
Mhm.
And I talk about optimization only, how you can use optimization for robotics.
Mhm.
So these are the two courses. But also on top of that, one thing that, I'm talking to other people. So I talk a lot to people from different fields. And I think one thing also is that is really missing in engineering fields is the social sciences. So we need to have courses about social sciences,
So why is that? Is it because we have those introverted computer scientists
Exactly.
which do not know how to
Exactly.
work or present their work? Or...
Not present their work, but basically it's really crazy because nowadays technology is shaping our society, right? And if we don't understand anything about the future of our society, how the society works, we are just single-minded people who just roll out the future.
Mhm.
And we need to think about these consequences. And yeah.
Also, so it's not only about how to behave, but more to take also all the problems of humanity into account
Exactly.
when you think about what you want to work on next, for example, right?
For instance, one thing is that, I see that many people talk about, okay, we have an aging society. We need to have robots to take care of humans. But first, we need to see if nurses and humans, elderly people, want this technology.
Mhm.
We should do some, start doing something, understand the dynamics of our society, understand what's missing, what's required, rather than without knowing anything, just start writing proposals. Okay, yeah, for sure, we need this into the future. But it's important. I mean, we are very bad at predicting these things, right? I'm not saying that we can predict, but still we should be concerned about that, and think about that. And then if something goes wrong, we can quickly detect it. So I think that's much more sustainable strategy, and that's missing in engineering curriculum. They don't know. Nobody knows how to think about this problem even.
Mhm.
And also another thing is ethics. I think ethics also should be part of the curriculum.
Okay, those are two topics which you would like to add. And so in terms of social studies, so what kind of topics do you actually have in mind as a course? So how could the curriculum there?
I don't know. I'm not an expert in this, but I know very good colleagues of mine in this area, and I talk to them, and basically I would need their help to do that, right? But still, again, to me, it's about understanding again the dynamics of the society and how technology is affecting the dynamics of the society, and then how we can measure and quantify, our new developments and technology affecting the society. I mean, mostly it's gonna be, through surveys and the so on, doing a study, asking people, going talk to people, and so on. But still, just acknowledging that such a science exists, right? It's not gonna be a deep, kind of course or so on. It's just like an introduction, and at some point, it keeps the student, maybe it a bit tickle the students' minds to think also differently. And that's very important, because otherwise we only think about math. We only think about, oh, how can I develop this new technology? This is super cool. I can get rich or whatever. But still, consequences are important, because if we just think a bit more about the longer term consequences, we don't know anything pretty much. So at least we can start teaching the students that, we should be a bit more responsible, because we really have effects on the society.
Yeah, I totally agree. And what would you say are actually the biggest problems which we face, maybe as humanity, maybe as society at large? So what in your mind is actually right now the most pressing problem or problems?
There are many problems. Again, we recently wrote a survey paper, and actually we wrote a full subsection on the societal impacts. There are many things. I mean, for instance, there is one thing is that robots will be used in military. This is clear, it will be used. It's being used at the moment. But at least what we can do is that we can say, I, as a person in academia, I'm against that, right? I'm a developer. I'm against that. I'm not going to get any funding from military and so on. This is one thing. But for sure, it's going to be used. And to me, being a responsible roboticist means that you clearly say what you think about these topics. And this is really important, which means that you're destroying some bridges, right? You cannot get funding anymore from military if you want. Especially if you're in the US, that's very tough. But Germany is much easier, I think.
And would you actually say that you are completely strictly against every or any use of robotics in warfare, or are you actually maybe okay with like using robots or technology as like some kind of defense mechanism where you only try to like do just for defending yourself and maybe for like searching for landmines or something like that?
There are international humanitarian laws, and using autonomous weapons is clearly against that, right?
Sure.
About the human right, it's clearly against that. Because if you have an autonomous weapon, it's clearly a very simple question. They do not feel the way a human feels. They don't know how dying means, feel and so on. So then it means it's just for the robot is just it's an enemy, just let's kill. At the end of the day, the enemy doesn't mean anything, right? It's just some social constructs in our mind. So I'm a bit idealistic in that area, right? I'm against any type of war. For sure it's not gonna happen, right? But I'm against it. Doesn't matter if it's gonna happen or not. I'm against any type of war.
And what about the right to defend yourself in case someone's actually attacking you?
Yeah. This can happen, but we should be moving toward not having this kind of authority which is not, again, it's the thing that I'm saying. I'm absolutely aware that it's very idealistic, right? I'm not saying tomorrow this is gonna happen.
Sure.
But this is I have ideals, and I wanna fight for my ideals, right? For sure, I'm not gonna achieve that, but at the end, maybe we get to some point that we use this for defense if you want. But for me, I'm against any type of usage. And this is not the only issue. Again, there are more issues, and also, they can make mistakes, right? It's important to tell people that these systems are not, they can make mistakes. And then when they make mistakes, who is responsible for that? We don't know. So let's say you have, I don't know, autonomous weapon goes to the battlefield, and at some point after a mistake, so they want to kill one person, but there are 100 people there, and they say, okay, it's fine. I'm gonna kill this person, but these 100 are fine to this is the price I need to pay to kill this person. And these are civilians, for instance. So it doesn't make any sense. And actually, even they can make mistake and do just, because it's a very difficult thing to distinguish civilians from combatants, right?
Yeah.
So there are many issues, so many. This real life is very complicated.
Yeah.
Math is very simple, and we say math is very difficult, but actually that's a very predictable world. Real world is very unpredictable.
Yeah, but I mean, still, humanoid robotics is also very difficult. And so let's get back to that again. And so one of your goals, I would say, is really to create humanoid robots which can solve like repetitive or dangerous tasks for humans. So what kind of applications do you actually foresee for humanoid robots?
So there are two ways of thinking about this. Okay. So for most of the application we see, right? Let's say you are in a factory and you want to just move around in the factory that's pretty much flat, and you want to do some tasks. You don't need legs, pretty much, right? But if you think about a specific task, most of the time you can say, I don't need a human. I can find a custom robot that can do this task like this. But for me, it's like, if I understand how to do humanoid, pretty much I have solved all the tasks, right? So this is the way I think about it. But in terms of application, it's still construction. Either we need to change the whole idea of construction, like 3D printing, building or something. But if we are doing the same way, we need humanoid for that to automate the procedure. Or if you need, for instance, firefighting, it's very dangerous for human, disaster response, all this kind of thing. Right? But Also, for instance, if you want to have a service robot at home, most probably it should be human, humanoid to do all the tasks that we do at home.
Yeah,
But yeah, it depends again.
yeah, I definitely agree. So, I mean, there's a very good case which you can make for humanoid robots, namely that, evolution spent millions of years to come up with an optimal design, and they came up with like humans for
Yeah.
doing daily tasks. But you could also make a case for the contrary, namely that for some very specific tasks,
Yeah.
for example, vacuum cleaning,
Exactly.
or just transporting people from A to B or flying people from A to B, we have come up with very specific solutions to those problems. And it seems that they are much better than the design we came up with evolution. So is there still like a case which we can make for using humanoid robots, or whenever we have a specific problem, maybe it's better to actually have like a specific hardware,
So again, I'm not looking at the base. I don't believe that human is the optimal morphology.
Mm-hmm.
And I don't think about it like this, but the way I think it is that to automate things in the world, you have two ways. Either to change the world, or you have built a robot that can work in this world.
Mm-hmm.
So the world around us, be human, change the whole shape. And we optimize everything for our shape.
Mm-hmm.
So now if you have a robot that has the same shape, most probably they can do everything that human wants, right?
Yeah.
This is the way I think about it. Otherwise, I don't think, again, it means that basically I'm looking at the applications that the robot can do all the things that human can do for the human environment. And for that, then it's difficult to think about any other, morphology or modality of, motion or interaction that would work better.
Mm-hmm. Yeah, that makes actually a lot of sense.
Let's give the example of, so we have the trains, and trains are working. So we had to make a lot of, rails and so on, so the train can work. And also we built our cities and so on with this, not that, but I mean, we already built a huge infrastructure of the streets and so on, right? Now, what you can do is that you can make your city compatible with autonomous driving, or you need to solve the autonomous driving problem in the city. So which one is better? I don't know. But most probably we need to adapt the technology to the environment we have rather than changing the whole environment for the robots.
Makes sense.
Yeah.
And so one big problem which roboticists face is this Moravec's paradox, which basically says that something which seems to be very easy for a human, it's very difficult for a robot to do, and the other way around. Why do you actually think that this is the case, and what can we do about it?
I don't know why this is the case. Maybe it's a very, very long time of evolution that gives us this physical capability. And the cognitive part is very new, right? It's not something that, so I think that has been much more difficult. The fact that it becomes very unconscious makes us feel that it's a very difficult, a very easy thing. While it's not easy, because it took a long, long time for us to develop a lot of species, gradually it started go from, in the sea to the on the land, and then just crawling on the land and then going on two legs and so on, right? It took a long time. But now the cognitive process that we are talking about, like, playing chess or so on, this is a new thing, right? And since it's more conscious, and for human it's very difficult, we think that it's very difficult for computers, but computers work differently. They can do a lot of computation, right? And they don't need to interact with the world, physical world. I think that's the main reason. So the things that are difficult for us, it's really easy for computers because they can do a lot of computation in parallel and, find brute force the solution. You cannot brute force solution in the real world. You need to do the job. You need to just, how many people or how many species died until now we can walk, And
Do you think we should actually follow the path of evolution to come up with those systems, or do you think it's better that we engineer it ourselves in the same way as we engineered flying, driving,
yeah,
vacuum cleaning even?
we cannot afford that, right? So it's clear we cannot go the path of evolution. It's very costly. It's very time consuming.
So you don't think that, for example, evolutionary robotics could be a good path forward?
You cannot do evolutionary robotics in the real world, right? You can think about doing it in simulation, which is again, it's an abstraction, which means that you are using human knowledge to build physics simulation. So this is already a shortcut. You are not going to a path of evolution. You can get inspiration and do evolution strategy, but it's not that you are going the path of evolution, which means that you trial and error, or I don't know, whatever in the real world for millennia, or I don't know for how many years, such that you do walking. We cannot afford that. So for sure we need to engineer this. But since it's very, just normal for human, we shouldn't be deceived that it's an easy thing. It's a super difficult thing, right?
So humans should be more appreciative of the things which we solve every day in the way of how we do motion.
Our hands is the most complex, most difficult thing ever, to me. So the body, the part of the body that always, impresses me is the hand. It's crazy. And we are far from having something that is even 1% of this hand.
That's a good change of topics. So what would you say are actually the main bottlenecks to move humanoid robots around in the same way so that they are also as useful as humans? So what would you say are really the big things which we have to solve?
I think pretty much everything.
Okay, yeah.
So pretty much we haven't solved anything, We just did a very, very few steps. So still, let's go back. Let's not talk about human. Let's talk about, can you have a quadruped robot that gets to the intelligence of dog? Still, we are not at all there, right? Or let's talk about the baby. Do we have that intelligence? Not at all. So let's not talk about the grown-up human, right? And I think that the last, just this fancy thing like playing chess, or I don't know, these kind of things it seems very difficult, but these are very early steps toward understanding how the movement in the real world works. And still, they are related. All of them are decision making, but still, they are really baby steps toward really going to human. So I think we should take a few steps back, right? Still, if we have something that is as intelligent as a dog or a cat, we should be very happy, right? And then the next step would be a baby. And then maybe, I don't know when we can go to the same.
So you would basically say the first step is to recreate a cat or a dog.
The amount of intelligence they have, not the morphology necessarily, right?
And so what kind of issues do we face there, and how would you basically divide the problem into smaller problems?
Yeah, there are many things that I have. Yeah. So I have some unpopular opinions that normally actually not everybody agrees with me.
Okay, I like that already.
So
go on.
I think the thing that people do nowadays, the focus of the research, I do not think we are going in that direction. So we are going in the direction that we need to have a lot of data to solve the problem. I don't think this is the way to go. But still, there are many smarter people than me that they think this is the way to go. So it doesn't mean that it's, that the community believes in it. But I personally, with a few others that, I talk to, I think it's not the way to go. This is the only thing, the way that we know how to do. There are difficult problems that we don't know how to solve, and we pretend that they don't exist. So for instance, one of the things that we as human, or most of the animal or a baby do, is that we do continual learning, which means that we learn a small task, right? And then when we learn a few tasks, it's not only for the sake of that task. for finding some invariances in the world such that we can leverage. And when we want to learn a new task, we can quickly learn that. This we don't have in the machine learning community, for instance. What we do is that we learn a task. For learning new tasks, we start from scratch again. And this is a very difficult problem. That's why nobody is thinking about that, I think. I mean, people are thinking about this. But in robotics, no, very few people are going that path.
So does it mean that you're not really a big believer in machine learning? But
of course, machine learning is important. No, I think I am a believer. But I think, machine learning is very vast, very big. I think the problems that are super important, we are not spending enough time on. So one of the things is that, so this thing I discussed a lot today and yesterday with people here in Berlin. And so one thing that we always deceive ourselves with is that we have a simulation. And then we can say, we can go to the simulation. We do not need to do the real world trial and error, and we do trial and error there. But to me, it's impossible to get a simulation like the real world, whatever we do, right? It doesn't matter. So there will be a gap. So at the end of the day, you need to at least fine-tune your behaviors in the real world, right? Which means that if you just do the current existing type of learning behavior, reinforcement learning behavior, all of them will just, break the robot quickly if you want to improve it. Which means that we are not going in that direction to solve it. How to explore in the real world safely. This is a fundamental question that will always exist, and we never could answer it. And we are not thinking about it. Why? Because we deceived ourselves that we can always go to simulation, and simulation, there is no safety problem. The robot can fly around, go, smash to the wall, and nothing happens.
And so what would you say is actually missing to have this kind of like continual learning in the real world?
There are many things. So first is the framework. We don't know how to do it. The second is safety. So if you go to explore for a new task, it means that you need to make sure that you are not breaking yourself, because that's done, right? So you shouldn't make catastrophic damage either to the environment or to yourself. And still, theoretically, continual learning is not very well established, framework, even in machine learning. Yeah, let alone the robotics side, because now it's much more difficult when you go to the physical world.
Yeah, even if we concentrate only, like, for example, on the task of moving a humanoid robot around, that's already like super difficult. So could you quickly explain why it's actually difficult to even like do motion planning, for example, for humanoid robots?
I mean, it's there are a lot of things that we are not conscious of, and we think it's super, easy because we are doing it just seamlessly without thinking. I mean, there are a lot. So if I want to just move around here, there are a lot of obstacles all over the place. And if I just, hit something, really, it can be as catastrophic as, I break my leg or break my arm. At the same time, if I do not put my foot in a proper place, I will fall down. That's going to be another catastrophic damage normally to myself. There are a lot of constraints on this system that we need to, just satisfy such that we do not damage our system. And again, since it's an unconscious behavior for us, we never think it's difficult. But if you want to write it down and reverse engineer that, it's a super difficult problem because you are making a lot of decisions at the same time. So coordination of all motors of the robot, which can be muscles of the human in the human case, such that you just take one step into the vision. And there is a very, very small coordination of these, values that will lead to a successful motion, which means that you will not fall down, you will not hit the environment, you will not jump down from this building, and so on.
So I think like a very common approach in robotics is to really have like a hierarchical way of seeing things, where you have, for example, like a task layer where you only say, okay, robot, please go from A to B or something. And then you have like maybe motion planning layer where you just compute like kinematics. And then maybe you have another layer for dynamics and another layer for controlling the robot. So do you think this is actually the right way to go about it? Or do you think we need like a different way of
So I'm sure we need hierarchy, I'm not sure if this hierarchy is a good hierarchy. This is the way we know how to do it. That's why we do it. But for instance, it's clear to me, I always give this example. Let's say I want to plan my motion going from here to the downtown of Berlin, right? Then movement of this, my finger, it doesn't matter. It's irrelevant. So if I just consider all the motions of my joints, it's irrelevant. I need to abstract it to such that I can make decision in such a long temporal, scale. Oh, I need to go to this point to get a taxi, or I don't know, take a bus, and then go downtown, and then in a more granular, more fine-grained level, I should go open this door, go out, and go to the stairs or elevator, go down, right? So for these kind of things, clearly how I move my eyes is irrelevant, right? It's in terms of dynamics. But now if we go to very, very short term, like 1 millisecond into the future, then every single motion that I do makes more, becomes important. So there are time scales clearly, and we need to do abstraction such that we can predict so long into the future. So let's say I wanna think about, I don't know, what is my plan in the next 5 years, right? So many things become irrelevant, many details become irrelevant, and it's important and finding the proper abstraction, I think, is highly related to intelligence.
And so you would say finding the right abstraction is really a problem of time domain. So basically something which is on a higher level has a different time scale compared to something which is on a lower level?
No, so I only talked about the temporal scale.
Yeah.
But also in the spatial scale, also we can think about abstraction as well. So it depends. Again, for the immediate motions I do, it's very important that I consider all the geometries and constraints. But if I want to go again to, then most of the geometrical part don't matter and so on. It's again, abstraction in space time, basically.
How would such an abstraction look like, actually?
We still don't know.
Okay.
Right. And I think it's a bit of a dynamic. So there are some task irrelevant abstraction that we always have. And sometimes we make task relevant abstraction, right? Again, for instance, if I want to grasp that glass, I just ignore all other dynamics of any other part, unless they are relevant for my task. For instance, if there is a ball moving toward this glass, then that becomes important. So the way we focus our attention on the task, we abstract, which means that we just ignore all other parts of the world. We only consider the parts that are relevant. Right? So it's a very complicated thing because, again, it has components on the task level and task agnostic level.
And if I look at your past publications, it looks like from all the different methods which we could use to actually control or move a robot around, you have concentrated mostly, I would say, on model predictive control. Why is that? And what do you think are advantages to other methods which you could use?
So this is important to me. So model predictive control, it means it's very simple idea. You say you have, some physics of the world on your robot. You predict in a short horizon into the future, the evolution of everything. Everything that is relevant. And then you make a path and trajectory that is, that satisfies your goal, right? This is what it does. So you always predict into the future. And there are a lot of evidence from neuroscience that we always do that. Even our perception is mostly based on prediction of the world. So mostly it's prediction plus some point measurements that we update our perception model, right? Also for the robot, this is a very dynamic way of doing this because now if quickly something changes in the environment, I can just adapt my plan based on that, right? But the other way that you can do it, again, you can, and this is very nice because if you do model predictive, it means that you do not need to test all your hypotheses in the real world. It can be very dangerous. So this seems very natural. If you look at so in the control theory, there is a very long history of this field. So it's a very mature field. If you look at the neuroscience, pretty much all the neuroscientists saying that, you have this kind of predictive models. So it seems the most plausible way. Still, the way we are doing it is very limited, but for sure we need an online prediction in some sense. Maybe we do not use the physics the way that we have the physics. Maybe it's just some abstract physics in some implicit representation that we do, right? But for sure, it's some part of the problem, some part of the full autonomous robotics problem.
And I think for me, at least, there's also this big problem of, I would say, like infinite choice in terms of what kind of contacts you make, because I can make like contacts with like everything in the world, and I can also like do it with a finger or 2 fingers or something. And so there's so much choice which I have. And so how do you actually take this into account, and what would be like a solution to this problem of where you make contacts in the world?
I think all of these are, we have infinite decision pretty much, right? Because if you look at the problem, if you assume that the world is continuous, for moving one joint, you have infinite, type of ways you can do that. And now we are talking about humanoid interacting with the world. It's infinity in the power of infinity, maybe, I don't know, something crazy. And the whole part of human intelligence is to just zoom in on one thing that is relevant all the time. And you're changing these sub goals that we have all the time, right? So basically it's about how we make our attention focus on something. And then we just simply filter all other things that are irrelevant, right? And again, we shouldn't just deceive ourselves that this is something easy because we can do it. We take it for granted. It's, I think we learned it over evolution. But now to reverse engineer it or find some shortcut to do it, it's going to take so much time because if you start thinking about this, you see, oh, it's crazy. How do we make decision? The world is very complex, and ourselves are very complex. At some point, we have very useful models, which are abstract enough that they don't need so much computation. We can predict few trajectories into the future all the time and take the one that is best all the time. And for most of the actually behaviors we do, especially the shorter term behaviors, we already learned it as a feedback control. We don't do much planning about it. So if you are walking on a flat surface, right, you are not planning. You're just doing a cyclic behavior that can be seen as a learned feedback policy. And mostly you do not need so much anymore your brain for that. But now if you go to a cluttered environment, quickly you need to be able to, plan. So it's super complicated. Still, we don't know how we decide, right? And it's very difficult because it seems that in each situation, we have a type of different task-dependent heuristic that we quickly ignore all the things that are irrelevant, for our task.
Yeah, it's really fascinating to think about this. And I think also another problem which is related to this is, so for example, you can first compute contacts with the environment, and then afterwards you compute like the motion of the robot. But then you have the problem that maybe the robot can actually not follow the context. And then you could also do it the other way around.
Exactly.
First the motion and then compute the context which follow from this motion. So what kind of those two approaches would you actually favor, and why?
So I would call one of them contact implicit, which you do not reason so much about where you just roll out things and you just modify all the time. And the other is contact explicit, that you explicitly plan for your contact. I think they have different functionalities. I think as we go through learned behavior, they are much more contact implicit. It's just a feedback policy. It doesn't care about where we put the contact and so on. But as we go to more conscious planning that we do in cluttered environment and so on, then we do more contact explicit. Because it's important to not put your foot, to not shoot this glass of water, or to not, there are a lot of things that can go wrong.
Yeah, I guess when it comes to climbing or something like that, then it's really important that you first think about what kind of contacts you make.
So if it's a very regular case, you don't need to so much do planning. And there you can do contact implicit, which means that do not reason about where to put your foot or arms or hands. You just, go forward with some feedback mechanism.
So you wouldn't say that one of those approaches is wrong and the other is
Yeah.
right, but instead it really depends on what kind of scenario you're currently in.
So I think so the way I like to think about it, we do a bit of contact explicit to plan in very difficult situations, right? But as we master the task, it becomes more and more implicit. We don't need to think about it anymore. We just do it naturally.
So basically, in the beginning, you plan your context and you try out what kind of motion, and then once you have mastered something, you basically just let it roll on.
I mean, many tasks we do it like this, right? First, when we start them to play an instrument or something, right? You're thinking about it or how to do the finger, and at some point it becomes really part of your body.
And some development from the industrial side, which I guess is really exciting to you, is that a lot of different companies have actually ventured in the humanoid robotics space, right? So we have, for example, companies like Tesla, Figure, Agility Robotics, but also like older companies like Boston Dynamics, Palm Robotics, just to name some, or even like Honda Asimov. So what do you think about this recent development of more companies going into the space, and which company do you think has like the right approach to building humanoid robots?
I prefer not to answer the last part.
Okay.
I have a very strong opinions that I don't want to put it there.
Fair enough.
But I think at this point, we still do not have the technology, to me. The technology is not there.
So you mean
the hardware is quite good now.
Yeah.
We didn't have it. There has been some breakthroughs in the hardware. Now we have decent hardware. There is no way close to human. It doesn't matter to be close to human. But still the part of the hand, we don't have any proper hand. So people sometimes argue you need 2 fingers enough and you can do repair most of the things. But if we think about really pushing this to the capability of human, we need a breakthrough still in the design of hand. So this is about hardware. In terms of software, I think we have a long way to go still. You can do, if you want your humanoid to just all the time pick a box from here, put it on table, that's fine. That we can do it this decade. But if you are thinking about cleaning a house autonomously, we are not there. Or if you want to do, I don't know. I mean, still, I'm not talking about something like firefighting or disaster response. These are much more complicated. I'm still talking about a confined environment, which is the same house. The only thing is that every day it's a new clutter, right? Differently. Still, we are not there.
But do you think, like in a factory setting, we could already like have humanoid robots for some specific tasks?
Some specific, if you are thinking about very specific tasks, I would argue you don't need the human.
Well,
this is the only. Maybe it's a baby step toward the general purpose robot, that I understand. But if you so much limit the scope of the task, you can quickly go back to the thing that do you need a humanoid? That would be the problem if you really limit it. That's why I don't want to limit it, right? I want to say, so my question is this. I want a humanoid that every day comes to this office. It's a different office, right? Everything is differently located. And now I give you the final picture that I want, and you should be able to do it.
So you mean in terms of like cleaning it up to the office and
moving a lot of things around, doing vacuum cleaning. If there are some water poured on the floor, you need to be cleaning. These are very difficult tasks. We don't have.
And what would you actually? What is your prediction about how far we are away in terms of like years
for this task?
Have some kind of home cleaning robot? Yeah.
I think we are far, because if we can solve it, I'm sure we have made a lot of progress. It's a very difficult thing. I don't know, and the number of years I can say most probably. I'm pretty sure this decade is not gonna be happening for sure. Next decade, I don't know. Still, I think we are far, but I've made a lot of wrong predictions, but I don't trust my prediction anymore.
Okay, so you don't want to like say, okay, 20 years and
I don't know. Whatever I say, it's gonna be wrong. Even if it turns out right, it's only chance. It doesn't mean that I have this intuition that this is gonna happen.
Yeah, I think a lot of those companies which are producing humanoid robots at the moment, they would actually argue, hey, we're just building big, large language models or foundational models for robotics, and they could actually solve things in a similar way as, for example, ChatGPT could solve like language. So what is actually your opinion on that? Do you think that is a valuable approach?
I think it can happen. Actually, I see it to be promising, but you need a lot of data, and the question is, where does that data come from? So one promising approach to collect data. So again, data of the language, data of the vision. That's the digital world. It's everywhere. You can train the language model on the whole internet and so on, right? We don't have such a data for the robots, right? We have data of human, but they are different morphologies. We don't have access to the actions, so it's very difficult to still infer from human videos how to. But the only thing that I see it's promising, especially for now, for the companies, is the teleoperation. So basically, you can wear some exosuit or some haptic devices and so on, and you show exactly the robot using its own embodiment how to do the task, right? And when you do that, this is exactly clean data that you want. And then you need a lot of human hours doing this task, getting master with these delays of exoskeleton and haptic device and so on, and making the robot do a lot of object manipulation, locomotion, and so on. That way, if you can hire enough people to generate these motions for you, I think this can do something.
So you would actually say the way towards this future would be by replacing not the humans with a humanoid robot, but instead like putting the humanoid robot in their place, and then maybe let this humanoid robot be controlled remotely by the same workers, but maybe from home.
Exactly.
So you can basically do remote work from home, and in that way you also collect the data for your humanoid robot, and then we can basically train things.
But still, you need the robot data, right? Only measuring human data, it doesn't matter.
Yeah.
So it should be something that translates quickly to the robot, and you, human, look at the robot and change your motion such that the robot does what you want, right? So it means that it's a full-time job for the human. It's not that the human can just relax and do its stuff. No, it needs a lot of really work from human, and it's a very expensive set of data. But I think this will scale. This can scale. And I think companies can benefit from this if they are willing to spend so much money on that, right? Basically, it would be human really spending time, teaching the robot how to do the things, right? And then let the robot do it the rest of the time. And still, we are talking about pretty predefined set of tasks, right? Again, cleaning the room is much more difficult. But for me, as a research problem, this is not very interesting. It's brute forcing basically the problem, and it's a shortcut to make what you want. But in terms of, as an industry person, I can see that this is very plausible.
And so you would say like easier tasks, which are maybe a bit more repetitive, they could be like solved with this approach.
Yeah, like warehouse tasks, like I don't know. Yeah, some parts of the, I don't know. For instance, in the automobile factories, there are still certain things that robots don't do, and they want to automate. I think for those kind of things, you can do this. But still, this is a bit, I don't think you can clean this room with that approach. The type of objects, number of situations are so many that you cannot iterate over them.
And so what would you actually say are applications which are nowadays already possible with a humanoid robot?
Inspection, maybe. But that people use actually quadrupeds. It makes more sense. People are using actually nowadays robots for inspection. And I actually have a project with CERN, and they want to use quadrupeds basically for inspection. Okay. Yeah, but that's a very difficult research problem still, because they have huge magnetic fields. And these magnetic fields affect the robot. Robots are out of metals all over the place. So we are finding a way such that we can do planning under magnetic fields, how we can modify the hardware such. But if it was not the magnetic field, you could do it with quadrupeds. Still, people do it on other, fields. And also, the thing is that, for instance, if you go to CERN, there are many stairs and so on. Really, you need legs to do the inspection. You cannot do with wheels. So it seems that this is a perfect, and they need inspection because, they need a robot because they cannot have many, many different cameras all over the place. You want to do, on a spot inspection or point inspection. So this way you can really use legged robot, but still, most probably you do not need humanoid robot. A quadruped robot is enough.
Nice. So your robots will go to CERN in a bit.
Hopefully, I don't know. Yeah.
Nice.
Yeah, there are 2 PhD students there that are supervised from there, and I'm co-supervising their project. And they are really pushing for that.
Nice. That sounds promising.
Yeah. That's one kind of application I would like to see.
If we stay with applications, what do you actually think about would be like some killer applications, and not like in the literal sense, but of course, like what would be like some really good applications which we might actually get to in like 10 or 20 years with humanoid robots?
So I still have to cleaning the room. Because that's such a difficult problem.
Yeah.
But still, the robot doesn't go out where, and there's no human here, right? I assume there is no human. So it doesn't matter if something bad happens, you're not killing anybody, or no damage to human.
Sure.
This is the first step if you really want to act in an open-ended world without the chaos of, the streets or outside of the world. So it's quite contained environment. The robot cannot, just diverge and, do something crazy. But still, there are a lot of detailed manipulation, local manipulations. So the robot should do vacuum cleaning. Sometimes it needs to clean below the table. So first it needs to move. Reason about I need to move first the table and do the vacuum cleaning. Bring the table back and then move the chairs first. There are a lot of kind of reasoning puzzles that also the robot should do. There are very advanced manipulation skills. The robot should move a paper up to a table. You see, the range of objects is crazy. And I'm not talking about just the same set of objects. Every day it's going to be a new set of objects, right? So that's the question. And sometimes the floor is wet, or there are some oil, poured on the floor, or a lot of random situation. This is kind of learning in the open-ended world. And if we can make something like this, I think that's a breakthrough. We understood something about how autonomous systems work, But if you limit so much the task and make the environment super controlled, then it's again going back to you don't need autonomy much. It's just you can have a pre-planned set of motions that can do the task.
And so let's assume that we are actually getting to this point where we can actually clean up rooms, for example, and we have like made this breakthrough.
Okay.
So of course you are replacing actual humans in this process, and this will definitely lead to unemployment. Yeah, do you actually feel that this might make people unemployed? And if yes, what could we actually do about it?
I think cleaning the house, it's good actually that if we can replace human. I don't know, right? It can be coming from my ignorance. For sure, people would prefer cleaning the house than dying out of poverty, right? It's clear, right? But I think this kind of tasks maybe are fine, and still many people need to clean their house themselves. So it's not gonna contribute so much into unemployment. But for sure, in the factory setting, it will, right? So maybe it's better if we talk about factory setting. There will be a lot of unemployment, I would say. Yes. In the past, we have seen that this didn't happen. So whatever automation we did, there have been more jobs, right? So, but I think this case is a bit different, and we might actually face unemployment. And then because it's a general purpose robot, basically it can be replacing human in any case, in any situation, right? It means that pretty much no physical task remains to do by a human if it's super successful, right?
Well, not every.
And the only cognition remains for a human to do.
Yeah, but for example, like painting and
Yeah, that's
sure,
fun,
something.
right? That's not something that you want to do to.
Yeah, probably not.
Yeah, these are cognitive curiosity, just being, but still, so it's an issue. And I think this is one of the other issues that, so the first issue I talked about a bit was the military. The second one is unemployment, for sure. And I think it's crazy if we consider that this will be solved just out of chance. With the current structure of the society we have, if we just, let's say, who will have the robots? Clearly the big companies, and they will have control over the everything. And then pretty much the people who lost their job, there is no way you can compensate for that unless you really define some ways that you can do it. There are many proposals that you can think about it. But if we just consider the current type of political and economical system that we have now, it's going to be a disaster if this happens. So really, we need to be thinking about it. And I'm really thinking about it, and there are many people who are thinking about it. And I'm pretty sure, if we really bring awareness to people that, okay, for sure, it's going to be super nice if we have robots, helping us in many things. But we don't want to, just make poor poorer and rich richer, right?
Yeah.
Because if you don't do anything, this will happen.
And so what, in your opinion, should we actually do about it? So
again, I have a bit of crazy ideas that might not be very popular.
Well, crazy ideas are always weird.
So I think we should have an international, basic income for everybody. People say, oh, people get lazy if you give them money. They do not buy food. They use drug for that. I don't believe that. I think there should be an international basic income depending on the economy of the country. Maybe I'm very naive and, I don't understand anything about the economy, right? But at least this would be my idea. So people wouldn't die out of poverty. They have food, they have shelter, right? And then the rest, they can figure it out, right? They can spend their time all the time in the house, do nothing, which is fine. Still, they do not, die out of poverty. They can just do painting all day, which is perfect. I hope this happens. Or they play music or spend time with the family or do some exploration in the woods or whatever. All of this would be my ideal society. They can really be free out of the 8 to 9 job or 8 to 5 job or whatever. They will be absolutely free. There might be also some downsides on this, right? So in the evolution time, we did things with our hand, physical things. I think, again, it can come from my naivety, but I think if we stop doing all of these things, it might not be perfect for our mental health. So we should do something physically, But I think that could happen. So if you have a basic income, such that people do not die out of poverty or not having shelter, and the rest they can go and do something for it to, innovate or whatever to gain more money, that's fine. Then I think this is the simplest way we can think about to safeguard this technology against, the problems of unemployment. But this is not my approach. But I think this is the promising thing that I've seen among the proposals. For instance, there are other things like, for instance, Bill Gates says you can put tax on the robots. There are many other type of proposals. The thing that I like, first of all, it should be international, whole world. Because if you put it on one country, then we will have all immigration to that country. This is something out of United Nations or something, should happen around all the world. I know it's super difficult to implement because it needs a lot of bureaucracy and a lot of administration. I understand all of this, but still I don't see any better way. So we should be thinking about how we can have basic income, and the money should come from, the benefit or the revenue of the companies in robotics. Maybe it's not very interesting for the entrepreneurs and the innovators nowadays, but if we really care about our species, I think we should be paying a bit the price, not being super selfish that, I want to have I want to become super rich.
So your ideal world would be basically that the robots are working in the mines, they're building all the resources, and then people can just get those resources for free.
It's not the ideal world for me, right? Ideal world would be that we would just say, okay, it's enough. We have good life. Let's stop innovating. We have enough money for food. We have enough money to spend our life. But I don't think that happens. So this technology is going forward, clearly. And I also contributed into that. And so I'm responsible for that, right? So that's why I wouldn't say that's my ideal world. I would say it's my ideal world within this trajectory.
And so how do you actually feel about maybe like AI and robotics being out of our control and at some point like taking over our world? Do you think this is a likely scenario? And
it's plausible, but I don't know if I think that would be the last thing that happened. There are much more dangerous stuff that might happen in between to get there. And if we survived all of this, I think we will survive that as well.
So what kind of other dangerous things could happen on the way there?
I don't know, a lot of things. So if you start using a lot of robots in the wars, and then this escalates, that's it. You're done, right? A lot of things can happen in the middle that are much more immediate, right? So there are many risks. We cannot just be the same to all of them. I wouldn't say, okay, there are a lot of problems with AI and robotics, and there are existential risks, but not that they take over the world and they kill us. I think that might happen. I'm not saying it may not happen, but I think that's much less likely than the other problems that are much more important. Again, it's plausible. I'm not saying it's not possible, but we should allocate risks. I would allocate them in the somewhere low priority.
So do you actually think that humanoid robots should also have like a personality or something?
So, but what do you mean by personality? You mean considered as an independent entity with rights, or?
Yeah, maybe this, but also maybe like how we actually respond to social norms, for example.
So I think again, this become much more philosophical, and I don't know much. I read a lot about them, but I'm not super informed about them. To me, so maybe we are going about so I think at that point somehow the suffering becomes important. If they suffer, feel the pain or not, right? That point is the point that we should consider them as, and that's super difficult because you can never I can tell you I suffer, but I can be a zombie. How do you know I suffer? You never know. It's a subjective experience. That's it.
Of course.
You can never say it. And then the humanoid can find somehow that, oh, it's a good thing, so I should say I suffer. And then we give them. So it's very difficult thing. I don't know. I don't know where is the point. I don't think that we want them to be like that, but I think it might happen. Right? So we should be thinking about that. I don't think, again, the way I think, the name of robot, it comes from, Czech Republic, and it means labor. And I think about it like that. Right? But at some point, if this robot becomes autonomous, maybe, I don't know. It's not a necessary condition. But they might, I don't know, start showing that I have a independent personality or something. I don't know.
And so you said that you read a lot about robotics. So is that basically the main thing you read about?
No, I actually, out of work, I don't read about robotics. I read philosophy a lot. I read, I don't know, I read physics. I love physics.
So you have a big library at home?
Not super big because I just moved to my new home, but it's growing fast. I like reading a lot.
And so what is your favorite philosopher?
Oh, it changes every day. Yeah, it changes every day. Sometimes it was Arthur Schopenhauer, sometimes Nietzsche,
Hmm.
but these are German, but also some of the French. I know, I mean, Albert Camus is not such a philosopher, but it's like really a thinker. I like him so much. His books are amazing. And again, it changes so fast. I don't know, and it's very difficult to detach their life from their thinking, right? So Nietzsche, was not a very, you know, female person. Sorry, a very feminist person,
Hmm.
right? But still, I mean, this guy was brilliant.
Hmm.
To me, it's clear. Or Albert Camus is brilliant, but still, they're not. It's not that I'm praising everything about them, right?
Hmm.
I just think about their thinking. Or Heidegger, to me, was one of the most important thinkers
Hmm.
from my life. I'm not a philosopher, right? I just read it as a hobby. But again, at the same time, he joined Nazi, right?
Hmm.
So it's not clear. But it seems that now that I just look, most of them are German, the philosophers I'm naming.
Well,
So I think it's, yeah.
maybe like continental Europe,
Yeah.
I would say
Yeah.
there's a big.
Yeah. And actually, recently I'm reading about the so there is a class of thinkers in the East. They are called the Kyoto School of Thinkers. And now I'm getting attracted a bit more and more toward the East philosophy, which is very interesting. They think much more different from the Western, philosophers. And
So what would be something very typical of them?
I don't know. I don't remember the names again. I'm sure I make mistakes of them. It's something very recent.
Mhm.
I just started,
Okay.
and I found it very interesting. But in the Europe we have something, or in Germany is something like Frankfurt School, right? Frankfurt School, they are very famous, and I think I like a lot of philosophers from there. And I didn't know such a thing existed in the East. And actually, the one Kyoto school, again, the person I don't unfortunately remember the name, he came to Germany, right? And he studied under the what's his, I don't know, supervision or class of Heidegger.
Hmm.
And then he went back to Kyoto and started his Kyoto school, which is somehow, again, a different type of philosophy, but he experienced the Western philosophy at the same time.
Hmm.
So Eastern philosophy is a bit different so Western philosophy always going back and forth from logic, right? It's always going by enlightenment is all about logical thinking but when you go toward the East, it's more about being rather than, so we are part of the universe, right? It's not that I am the subject and this is the object. We are all, it's more toward that. And actually Heidegger has the same, so he has the term Dasein,
Hmm.
and it means that, the mode of existing, just being there is the most fundamental thing.
Hmm.
So, yeah, there are many. Again, and every day I change my mind. So whenever I read a new thing and I get super excited, I say, "Oh, that's what I." And then the next day I say, "Oh no."
And would you say that reading philosophy has really influenced your life, and maybe you got like some actionable advice from all those philosophers?
So for me, it didn't happen like that. So at some point, I experienced some existential crisis in my life.
Mhm.
I thought, what am I doing? Why am I doing something that I'm doing?
Mhm.
And then I started saying, okay, what other people think? How? And then when you go back and see, oh, many people just thought the same thing. And then you start reading this, and then you understand that nobody has an answer. And then you say, okay, I don't know. You just at the end say, I don't know, because nobody has an answer. It's super complicated thing. So yeah, I mean, this is already a very complex thing because we as a human are studying our brain, something that makes us human.
Mhm.
And that's already very crazy. It's such a loop for me. If you understand it very well and we can recreate it, I think we are creating a loop here. Really, it
Yeah.
means that we human, we are creating human. What does it mean?
Mhm.
Not that we do through evolution and but we are just building an artificial human. I don't know what it means.
Well,
It's crazy.
yeah. And so something which I really love about Nietzsche and Schopenhauer, for example, is that they also like published some work which was really like easy to understand and also like very, very applicable to human life.
And these were mostly existentialist movement, right? At some point, if you go back a bit to Hegel, you understand nothing.
Yeah,
What's the reading?
that's true. So I never read it, but I heard that it's I think he even like wrote things in a way so that other people have like a hard time to understand it because he saw that you need to be like very intelligent to follow his prose.
I don't think it was his intention. I don't know, right? But I think he wanted to be super precise. And it's impossible. Language cannot be super precise.
Well, mathematics.
Mathematics also can be seen as a language, but it's still, Gödel theorem is there. And then you see that there are problems even for the most formal language we have.
Yeah, maybe we can just quickly go back a little bit.
Yeah,
to the research. So what are actually current projects in your lab which you're currently working on?
Yeah. So again, so you need to have a bit long-term picture. And again, my long-term picture is that I want to tell a robot, a humanoid, to clean this office. And the robot autonomously does it without me telling it what to do. Nothing. I just give the robot this picture. This is the endpoint. And of course, I want to put some constraints that, you shouldn't, the robot would not break something, right? Because it wouldn't be like the picture. I just should make sure that it doesn't come up with some crazy thing that I don't think for this case it happened, but still. So if something also happens, I think it's nothing bad. I understand there is something that I need to really safeguard. And now this is super complex. We need to break it down. So I have a couple of projects. So one is that how to do task and motion planning for humanoid. And task and motion planning means that rather than saying first do this and do that and do so on, you just do first task planning and then motion planning. You do it at the same time. So you need to see the limits of motions during the task planning and the other way around. And this is already very complicated, right? I have one student who is using, so again, the goal is to realize this. One thing that I see very promising is to use the human data on the internet to just, give an initial guess how to do that, right? And this is something we are looking at because human already solved the task, right? So we try to get some intuition from that. We are doing a bit of, and then the rest is technical, right? So for task and motion planning, you need to solve a research problem, how to warm start research, how to find, you worked a lot on this, so it's, and then the motion planning, I do optimization. We try to find what's the best optimization algorithm to use. So it becomes much more technical.
Makes sense. And so if you look over all the research which you have done so far, what would you say is actually the thing which you're most proud of?
I would say the work I explained during my internship at Max Planck.
So that's 1 year during your PhD.
Yeah. I think it was, I thought a lot about the problem. And it was, very simple algorithm. It gives guarantee. That's, which means that when it gives guarantee, it gives you some understanding about the problem.
And I think it's also very much highlights this, what you said in the beginning, that you really think about equations in a way of how do actually the objects themselves, how do they actually propagate forward in time. And I think a lot of people don't see problems that way, but the way of how you actually approach it, you had like this new insights there, and that is actually how you came to this point where you said, okay, why not make a step, right?
Yeah,
that's the right thing to do to counteract the force if you have actually the ability to do it. So
I love simple solutions that give you insight, and this is one of them.
Nice.
Yeah, and still it's quite powerful because it gives you something that you say, oh, it can work, whatever, right? So that's that. I think that's the thing that I'm so. At the moment, I didn't think that again. It's always in retrospect.
And if you would have like infinite resources, infinite time or something, what would you actually maybe change about the research landscape? Maybe not only in Germany, but maybe like globally. So do you think the way we do research is a good way, a right way? Or do you think there needs to be like some bigger changes?
No, I think there are many things that should be changed.
So
The first thing
what
should be
changed?
the funding system.
Mm-hmm.
It doesn't make sense to make it super competitive. We don't need that. There are certain issues that we should work together to make it work, right? And it's crazy how much for every single thing we make it super competitive. I think, research is super incremental. We should really diversify the way people tackle the problem. So it makes more sense to a bit be more socialist, a bit, right? And a bit more distribute the money rather than just saying, oh, 1% can just take all the money and the rest have no money, I think the funding system is super competitive. It shouldn't be. And it would be much less work if you just simply distribute the money rather than just you have the review system, proposal writing. There's a business around this. It's crazy how much energy and time is spent on this. And it's crazy because, for instance, you need to write 25 pages of proposal. You don't need that. 1 page is enough. You write it. It's crazy because now we write this. It goes to reviewer gives it to ChatGPT, summarizes for me. It's crazy. I mean, I don't understand what we are doing. It seems that the thing at the end, we should just write very short. You write proposals are not research papers. There is no result on this. It's about idea in the future.
And it's also about that we are taking so much resources away from people doing actual research, right?
Exactly. And people who are not doing the mainstream research, they are focusing on something that is not mainstream, so it's not going to be funded. But also, it's still diversifying our solutions. Why not do that? Why should we put, everything in one direction? I think for sure we should diversify that.
I think one idea there is to just take all the proposals and then randomly choose the winner, right? So do you think this is actually a valuable approach?
Absolutely. First of all, you just reduce the number of pages, right? It become 1 page or 2 page, because at the end it's the idea. And the person who has done this thing for 20 years will not come tomorrow and do something absolutely different. The person is gonna do the same thing. The only thing that he or she will do is that she or she will pitch the idea through another thing to get another funding. It's the same thing, right? So this means that one person can just, I don't know, I don't want to say it's a lie, but it's just pitching the same thing in different directions and get funding and funding and funding. And this is only one solution, right? And then again, the other 10 persons who are there and they are doing something else that, maybe it's promising if they are given more money such that they can spend more time on it with more people. But also, yeah.
Don't you fear that? So if you just randomly distribute like the money,
but not all of it, some of it, not all of it. So we should be a bit more social, not fully social system.
Okay. Yeah.
So I think somewhere in between. Still, there should be some competition, right? Such that okay, still it's not a fair competition. There are a lot of biases, and since the ideas are very difficult to judge an idea. It's not like a scientific paper. You look at the plot, oh, this is better than this. There is some idea, and reviewers are other researchers. So it's already a bit random process because it goes to a reviewer that says, oh, the reviewer thinks like you, and then you say. But still, I think we shouldn't. Again, it seems that the system is such that some people can hack it and get all the money. And for me, I myself don't do it. So if I get enough money, I stop writing proposal.
Well, yeah, you also want to do actual research.
Exactly. That's the idea. It's not about just getting money that you make a company or a very big system, right? It's not that. It's about doing research. That's why I'm here.
Yeah, a very good end sword, I would say. So yeah, Majid, thank you so much for being here.
Thank you.
It was really great.
A lot of fun. Thank you.